Hello! In this video, we will look at the process of recovering data from mdadm RAID 0, 5, and 6 arrays created in the OpenMediaVault 8.2.8 operating system. We will analyze the most common data loss scenarios: accidental file deletion via SMB, NFS, or FTP network protocols, data corruption due to the failure of one or more drives, hardware failure of the server or NAS device, as well as software glitches in the OpenMediaVault operating system caused by updates or critical errors. We will show how to diagnose the status of the array, connect drives directly to a computer, and determine key parameters: drive order, block size, and data offset for manual RAID reconstruction using specialized software. The described methods and tools are universal and suitable for working in Windows, Linux, and Mac OS. OpenMediaVault is an open-source software system designed specifically for building network-attached storage. It is based on Debian Linux and is aimed at home users and small businesses who need a simple, reliable, and flexible solution for network file storage. The system is managed through a user-friendly web interface, so its configuration does not require deep knowledge of Linux or the command line. A key advantage of this operating system is its powerful and flexible disk space management. OpenMediaVault has built-in support for software array management via mdadm utility, allowing you to create fault-tolerant or high-speed configurations such as RAID 0, 1, 5, and 6. Integrated smart monitoring mechanisms ensure continuous tracking of physical drive health, warning of potential hardware issues in advance. The main feature of mdadm software arrays is their high portability and absolute independence from hardware. Since the RAID architecture, specifically levels 0, 5, or 6, is formed entirely by the software of the operating system, such arrays are not rigidly tied to a specific RAID controller or your NAS device's motherboard. Before starting the recovery, it is important to understand how many drives from the array must be present and in working order. RAID 0 requires at least 2 drives and is the only level discussed that has no redundancy. The failure of any single drive immediately makes the array unreadable and all data inaccessible. RAID 5 is a more secure solution and requires a minimum of 3 drives. In addition to the data itself, the system writes parity blocks that are evenly distributed across all the drives in the array. In the event of a single drive failure, the algorithm uses these checksums to mathematically reconstruct the lost information based on data from the remaining functional devices. Thus, the array remains fully operational until the failed drive is replaced. RAID 6 is the most resilient of the levels discussed and requires at least 4 drives. Unlike RAID 5, it calculates and stores 2 independent sets of checksums, allowing the array to withstand the simultaneous failure of 2 drives without losing access to data. This exact characteristic makes RAID 6 the optimal choice for environments where storage reliability is a priority. You can connect drives to a computer in several ways depending on the available hardware. The simplest and most reliable option is connecting via the SATA interface directly to the motherboard. This ensures maximum data transfer speeds and minimal latency during reading. If there are not enough SATA ports on the motherboard, you can use a PCIe to SATA adapter, which allows you to connect 4 or more drives simultaneously. For quick connection without opening the computer case, it's convenient to use external USB docking stations or SATA to USB adapters. However, this option has lower data transfer speeds, which can be noticeable when working with large volumes of information. It is also worth considering working with disk images. This approach is especially relevant when the drives are physically damaged or when there is a risk of further degradation. To create an image, launch the program, select the desired disk from the list, and click Save Disk. In the window that appears, specify the location to save the file. Please note that the image size will be equal to the full capacity of the source disk, regardless of how much of it is filled. Therefore, make sure in advance that there is enough free space on the destination drive. Once the image is saved, go to the main menu and select Mount Disk. In the list of types, select Raw Disk Images and load the file. It will appear in the list of devices alongside physically connected drives. If there are several problematic drives, repeat this procedure for each one. Once all array components are present in the system, either physically or as images, the program will automatically detect the RAID configuration and display its structure, ready for analysis. Let's look at the algorithm of action for the most common data loss scenarios. We will start with hardware failures, a complete halt of server hardware, failure of its internal components, or damage to individual drives in the array. These situations are most often the reason why the operating system stops seeing the array and access to data is completely lost. This category also includes critical failures of OpenMediaVault itself, situations where the system does not boot or works incorrectly after an update or system error. Under such circumstances, the only way to gain access to the drives is to connect them to another computer, bypassing the damaged environment. A separate group consists of user errors. The most typical of these is accidental file deletion via the Shift+Delete key combination, which instantly destroys data without moving it to the recycle bin. Although such a loss seems irreversible, in most cases the information can be recovered using specialized software, as the data physically remains on the disk until it is overwritten by new files. To resolve the described problems, we will use Hetman RAID Recovery, a specialized software developed for the automatic and manual reconstruction of failed arrays and the safe extraction of files. The main advantage of this tool is that it allows successful recovery of information, even in the complete absence of the original NAS server or the motherboard on which the array was created. The utility is multi-platform and works fully in Linux and Mac OS environments. In this video, we will perform the data recovery operation using Windows 11 operating system. You can find the link to download the current version of Hetman RAID Recovery in the description below this video. After physically connecting the extracted disks to a Windows 11 computer, first open the Disk Management System utility. Make sure all drives are successfully detected by the system at the hardware level. Crucially, if Windows prompts you to initialize or format these drives, be sure to reject this offer. Any initialization actions are guaranteed to overwrite metadata and irreversibly damage the structure of your array. Once the automatic reconstruction is complete, the program will display the array on the main screen, indicating its type, total capacity, and file system. To start searching for data, select any disk from this array and run the fast scan mode. The program will scan the metadata and file system directories, detect lost elements, and evaluate their state. Upon completion, the screen will display the entire contents of the array available for recovery, and the preview function will allow you to check the integrity of the found files. To complete the process, select the necessary files and click Recovery in the main menu. Specify the destination path on another healthy storage device and confirm the action by clicking Recovery again. The program will preserve the original folder structure and file attributes. After copying is complete, click Finish, and the recovered data will become available for further work. If the program fails to automatically recognize the array or the fast scan result is insufficient, use the full scan mode, which performs a deeper scan with the option to manually specify the file systems used in the array. Let's consider a practical example of recovering a RAID 6 of 4 drives in which 2 drives failed simultaneously or the array was accidentally formatted. RAID 6 was created specifically for such situations. Double parity allows recovering data even in the event of losing 2 drives at the same time. However, a successful outcome directly depends on the accuracy of reproducing the original array configuration, as in such cases, the program may not detect its structure automatically. For reconstruction in such a situation, you should use the RAID constructor tool in manual mode, where you need to specify the drive order, block size, and parity parameters. For RAID 5, the sequence of operations with RAID constructor is similar, but it only allows the loss of a single drive. In the case of RAID 0, recovery after the loss of any drive is impossible through software means, since this level does not contain any redundant information. To work in the manual mode of the RAID constructor, you need to know the basic parameters of the array in advance. In our example, the following values are used. Block distribution type is left synchronous P plus Q. Block size is 512 kilobytes. Sector size is 512 bytes. These parameters are specific for each configuration and may differ depending on the settings applied when creating the array in OpenMediaVault. If the exact values are not known, they can be determined by guessing and checking directly in the program. RAID constructor allows you to cycle through options and evaluate the result before launching a full scan. In the constructor window, move the required drives from the Available Disks panel to the Selected Disks list. At the same time, it is critical to strictly follow their original hardware sequence, otherwise the logical structure of the array will assemble incorrectly and file recovery will become impossible. If a certain drive is physically missing or unreadable, use the Add Empty Disk function. The virtual empty disk created should be placed in the exact position where the missing drive was located. This will allow the program's algorithms to correctly calculate the missing pieces of information from the remaining working drives. In some array configurations, the actual file system data does not start from the very beginning of the disk, but with an offset, a certain number of bytes occupied by the service area. If this information is corrupted or missing, the program cannot automatically determine exactly where the file system begins and requires manual entry of this value. This parameter is called offset and specifies the exact position where data begins on the disk. If you set it incorrectly or leave it blank, the program will either not see the file system at all or will display an incorrect directory structure with missing files. In our example, the offset value is 135,266,304 bytes. This exact number must be entered manually for each physical disk during the reconstruction in RAID constructor. If some of the array parameters are unknown, they can be determined directly in the program using a trial and error method. The reference point is the result in the preview window. Correctly selected values will result in the appearance of a partition with a recognized file system and a readable directory structure. This is the main sign that the array logic has been reconstructed correctly. To simplify this process, the program includes a detect automatically function. It automatically runs through possible combinations of parameters, drive order, block size, and offset, and determines the most likely configuration. This mode is indispensable in situations where the technical information about the array is completely lost. The process of scanning and checking millions of combinations usually takes significantly longer compared to simple manual entry. After entering all parameters, click Add, and the array will appear on the main screen of the program and will be ready for scanning and file recovery. Once the reconstructed array appears in the device list, you can proceed to scanning. Depending on the cause of the data loss, configuration failure, drive failure, or accidental overwriting of RAID technical information, start with a fast scan. The program will quickly analyze the file system metadata and display the existing structure of folders and files. Before starting the recovery, use the preview function to ensure the readability and integrity of the required files. If the fast scan result is insufficient or the file system has serious damage, run a full scan. This mode performs a deeper analysis of the entire array space and allows you to find files even in complex cases. Once the scan is complete, mark the directories and files you want to retrieve and click Recovery in the main menu. In the dialog box, specify the destination path on a separate drive and confirm the action by clicking Recovery again. Upon completion of the operation, the program will report successful data recovery. Conclusion. In this video, we looked at the practical process of recovering data from mdadm RAID 0, RAID 5, and RAID 6 arrays created in OpenMediaVault operating system. If this material was useful, subscribe to the Hetman Software channel. There you will find more practical instructions on data recovery in various scenarios. Please leave your questions and comments on the video topic below. We reply to each one. Thank you for watching, and we hope your data always remains safe.